So let's talk about graphing exponential functions. So here are some characteristics of the graph f of x equals a to the x. The points when x is -1, y is 1 over a will always be on our graph. The point when x is 0, y is 1, and the point when x is 1, y is a is always on our graph. Let's think about why this is. So if I have f of x equals a to the -1, that's going to be 1 over a. Aha, so f of -1 is 1 over a. If I have f of 0, that's a to the 0, which is 1. And if I have f of 1, that's a to the first power, which is just a, which is why these 3 points are on my graph. If a is greater than 1, then it's an increasing function. If a is a fraction, we saw that with 1/2, right? It's a decreasing function. The x-axis is a horizontal asymptote, so my graph does not cross the x-axis. My domain is from -infinity, and my range goes from 0, but 0 is not included, all the way to +infinity. So why don't we go ahead and graph a few functions. So I want to graph these, and I also want to state the domain and range. Let's talk real quickly about if I have f of x equals 3 to the x minus 4. Now, we've talked about transformations of graphs before. If I have a -4 not attached to the x, this shifts my graph to the left or to the right, right? This is an example of a horizontal shift. And in this case, it is to the, this is an example of a vertical shift. And this is a vertical shift that is down 4, right? If I have it outside, not attached to my x, that's going to be a vertical shift. So if I'd had f of x equals 3 to the x, when x was -1, y would be 1/3. When x was 0, y would be 1. And when x was 1, y would be 3. So I'm going to go ahead and graph this in blue, and then in orange we'll solve for our given function. So when x is -1, y is 1/3, 1, and 3. So here's my function again. My x-axis is an asymptote. This is f of x equals 3 to the x. Let's see how different my graph looks now that I have f of x equals 3 to the x minus 4. So I've got my x and my y values. When x is -1, I have 3 to the -1 minus 4, which gives me 1/3 minus 4, which is a -3 and 2/3. When x is 0, I have 3 to the 0 minus 4, which is 1 minus 4, which is -3. When x is 1, I have 3 to the 1 minus 4, which is just going to give me a -1. So let's graph these points. I have when x is -1, y is -3 and 2/3. When x is 0, y is -3. And when x is 1, y is -1. Here's my new function. It's been shifted down 4. My domain is all real numbers, but my range has changed, and here's why. My new asymptote is when x equals -4. So my range goes from -4, not including -4, all the way to +infinity. Let's do another example and see why this is a decreasing function. Here we had an increasing function, right? As I go from left to right, my function takes on greater and greater and greater values. Let's take a look at why this is a decreasing function. This function is not shifted vertically or horizontally. So when x is -1, I have 1/2 to the -1. Well, that's 1 over 1/2, which is 2. When x is 0, I have 1/2 to the 0 power, which is just 1. When x is 1, I have 1/2 to the first power, which is 1/2. I'm going to find a couple more values. Let's show that when x is -2, y is 4. When x is -3, y is 8. I'm going to graph this for us. So when x is -3, y is 8. Okay, that's up here. When x is -2, y is 4. When x is -1, y is 2. When x is 0, y is 1, and when x is 1, y is a half, okay? Woo. So this is a decreasing function. I can't draw a straight line. This is a decreasing function. It's decreasing because as I go from left to right, my values get smaller and smaller and smaller. My domain, because this graph was not shifted, goes from negative infinity to positive infinity. And my range, again, because my graph was not shifted, goes from 0 to infinity. The last thing I want to talk about is solving exponential equations. So, if a to the u equals a to the v, then u equals v. Good to know. So let's take a look at these four equations. If I have 2 to the negative x equals 16, well, I could rewrite 16 as 2 to the 4th. So I have 2 to the negative x equals 2 to the 4th. This means negative x equals 4, so x equals a negative 4. If I have 3 to the 2x minus 5 equals 9, I can rewrite 9 as 3 squared. That would give me 2x minus 5 equals 2. I add 5 to both sides. 2x equals 7. So I find that x equals 7 halves. For problem 3, I have e to the 2x equals e to the 5x plus 2. So I can automatically take 2x equals 5x plus 2. I subtract 5x from both sides. I get negative 3x equals 2. So x equals negative 2/3. Let me rewrite this bigger. This implies x equals negative 2/3. Now for problem 4, things are a little different. I have e to the x squared equals e to the 3x times 1 over e squared. I need to rewrite this right-hand side as one exponent with a base of e. So if I have e to the x squared, that's e to the 3x. Remember, e to the x, 1 over e squared is just e to the negative 2x. And that when I'm multiplying exponents with the same base, I add their powers. So now I have e to the x squared equals e to the 3x minus 2. I'm going to change colors so you can see what's going on for problem 4. Now I have x squared equals 3x minus 2. I'm going to go ahead and move everything to the left-hand side of my equation because this is a degree 2 quadratic, and I know I'm going to have to factor. So I subtract 3x from both sides and add 2 to both sides. That gives me x squared minus 3x plus 2 equals 0. And I say, okay, what are the factors of AC, which is 2, that add up to b, which is negative 3. That's x minus 2 times x minus 1 equals 0. So I get x equals 2 and x equals 1 as my